In this video, I want to show the basic idea of machine learning from start to finish. We'll build a very simple model that learns how to recognize a heart shape from pixels. The goal is not to build a perfect model, but to walk through machine learning pipeline, understanding the workflow from raw data to making predictions on real images. First, we create our own dataset instead of downloading one. Each image is 32 by 32 pixels. That means every image can be represented by 1024 numbers, because 32 times 32 equals 1024. We generate two types of data: 1000 hearts and 1000 non-hearts. Here we use circles, squares, and triangles. So the dataset is balanced because 1000 and 1000. Each row in the CSV file represents one image. Here each image is just a single shape. Totally we have 1026 features. One column for shape, another is a target feature. Is heart or not? 1 means heart, 0 means not a heart. So we create our shapes.csv file. Okay, this is our shapes.csv file. Text column, so heart, non-heart, and the label column is heart. 1 means heart, 0 means non-heart. Here are some samples from our dataset. We didn't add any noise, so each image is clean. We only change the location and size of shapes. This keeps our dataset simple, so we can just focus on machine learning workflow. Since our dataset is ready, let's start the machine learning pipeline. I loaded all the libraries at the top to make the code clean. Later, I will explain each one when we use it. Like scientific computing libraries, NumPy, Pandas, and the visualization library, Matplotlib, image processing, and here are machine learning libraries from scikit-learn. Step 1 is getting the data. Our data is a CSV file where each row is an image. Our dataset structure includes 1024 pixel columns because machine learning does not say images, it only says numbers. So all the features shape is hot, then the pixel columns. Now in step 2, we need to prepare our data for the models. Our dataset is already clean, so we don't need any data cleaning. We separate the pixel values as our input features, X, capital X, and the is hard column as our target, Y, the lowercase y. Here 1 means hard, 0 means not a hard. X in capital for the input data because it usually represents many features like a matrix. Y in lowercase for the label because it's a single value we want to predict. Now we come to step 3, data splitting. So 30% for testing, 70% for training. We set random state 42, so we get the same result every time we run the code. Stratify is super important for classification problems. It makes sure the train and test sets keep the same ratio of hats and non-hats. Here we use scikit-learn's train test split function. So this train test split tool from scikit-learn model selection helps us separate the training data from test data. Now we move on to step 4, training the models. At this point, we only use the training dataset. Here I'm training two models from scikit-learn. The first one is logistic regression. It's simple and works as a good baseline. The second one is SVM support vector machine. This model can learn more complex nonlinear patterns. Let's quickly jump back to the input cell. You can see both models come from scikit-learn. This is where logistic regression and SVM are defined. Okay, we know models look at the pixel values and the labels and try to find patterns that separate hats from non-hats. Training means adjusting model parameters using the training dataset. Now let's evaluate the models using the test dataset in step 5. This data was not used during the training. The training is 70%. We use the remaining 30% as a test dataset, so we can tell the model performance. Okay, before we look at the numbers, let me quickly jump back to the input cell. Here you can see we are using evaluation tools from scikit-learn, like accuracy and the confusion matrix. This helps us understand not just how often the model is right, but how it makes mistakes. Okay, let's look at the results. Logistic regression reaches about 89% accuracy. SVM is about 94.5% accuracy. Accuracy is useful, but it doesn't tell the whole story. That's why we also look at the confusion matrix. The confusion matrix shows us what kind of mistakes the models make. Let's read the confusion matrix. Based on the confusion matrix format, A and D are correct predictions. B and C are errors. B is false positive. That means seeing a heart when it's not. In medical diagnosis, labeling a healthy person as sick. C is false negative. That means missing a real heart. That's usually more serious, right? Really dangerous errors. Missing a sick patient. It's worse than labeling a healthy person as sick. Logistic regression misses 34 hearts, and for SVM is 8. Now let's talk about precision and recall. Precision means when the model says heart, how often it is correct. Both models do well here. 90% precision, here is 92. So out of all images predicted as hot, 90% were actually hot from logistic regression model. SVM model, out of all images predicted as hot, 92% were actually hot. So high precision means less false alarms. And for recall asks a different question. How many real hearts does the model actually catch? So out of all images predicted as hot, logistic regression found 89% of all real hearts. SVM model found 90% of all real hearts. Here is a summary. We know SVM model is the better choice. And again, in medical diagnosis, missing a sick patient is worse than mistakenly labeling a healthy person as sick, right? So here, the matrix, the C, missed the heart, right? It missed a real sick patient. That's really dangerous. In many machine learning workflows, pre-processing is included as a part of prediction. So step 6 and 7 should be just one step. So after step 5, it just comes to step 6. Prediction includes the pre-processing. But here I separated them in 2 steps. Just for the clarity, it's easier to see what's happening. This image pre-processing function converts any images like JPEG or PNG into the same format as our training data. I just downloaded this heart shape and this triangle, so you could save image as PNG file. So this pre-processing function resizes the image to 32 by 32, converts to grayscale, and turns into a clean black and white image. If the background is white, it automatically inverts the image. Now the image is ready for the model. It's aligned with our training and test data, 32 by 32 pixels. So in the end, every image becomes a vector of 1024 numbers. Before we make predictions in step 7, let me quickly jump back to the import cell. You can see both logistic regression and SVM come from scikit-learn. So here we have the model class, then we call the predict function. We give these two models completely new images they've never seen before. So here we have heart triangle. Both images go through the same pre-processing function. Then we pass the result into our trained models. Our models recognize the heart shape, reject the triangle. In this video, we use a very simple model to show the basic machine learning pipeline. Our dataset is clean and noise-free, so we skipped some steps like data cleaning. In real-world projects, datasets are much messier and the process is more complex. But the goal here is to show the big picture of how machine learning works from data to prediction.